So good afternoon, and thanks for coming to my talk in this afternoon time, the last time slot session of the conference before we get to the closing keynote raffles. So I planned some live demos in my talk, and I apologize in advance if those don't go as I planned. So we don't have too much time if we want to speak about this topic extensively. So I try to be fast. My name is Csaba Toth, and I'm a GDG Fresno lead and local developer working remotely to the Bay Area and some local consulting. And yeah, I think I will try to talk about not just version control and Git, but general concepts of how you enforce rules, and this is also points towards security, what we heard if you've been to the previous talk, and best practices in general. Version control alone itself is a best practice. All of the version control systems, almost all of them are based on the diff utility, which is an old Unix utility. It can compare text files. And basically, it summarizes for you the difference between the two files. Here, in this case, all of the 3 lines of the file is removed to get to the next version, and you have to add 3 separate lines. So kind of the whole file is replaced. But also you can see markers. This is standardized. Markers, which line this section starts, this change section starts, which line it ends. And this can become important when others also modify concurrently the source. And so these lines might not exact. Then the logic tries to find the environment area, the preceding lines, and the following lines. But anyway, in practice, the version control systems don't use the ignore white space, but when you are working with graphical utilities, because of some, you are developing your own source code, and somebody was using different white space settings, it might sometimes beneficial to ignore white spaces. But when the version control system uses the diff deep inside the core, it doesn't do that. But when you do it manually, you can. Also, when I will show you some GUI tools, graphical tools, they are not necessarily line by line based, what you saw there. They can also highlight just certain words within a line which changed. Yet again, the version control doesn't do that in the core, but when you try cognitively see a situation, discover what happened, this is much better to interpret cognitively usually when you, for example here, right here you see a graphical tool, and on the top, we can see that this is the exact word which changed. It's less evident when you see the other view, but fortunately, yet again here, the graphical tool helps with the coloring and the extra highlight coloring. Your brain can interpret it cognitively better. And actually, this is one reason I like graphical tools. I'm not against, I mean, even Vim and Emacs can do highlighting, of course. But you always need to find the most efficient tool you can use. And sometimes I am in command line. but sometimes I'm in the graphical land, whichever is more efficient. Efficiency is the key. So diff is kind of one of the basic building block of all version controls. And if we go back in time, the early systems, like this is a specific software, these are the first generation systems basically. This particular one, it wasn't even ready to share the code in multiple computers. Back in the day, you had a big mainframe, and everybody was logging into the same mainframe, and it was just one machine, multiple users. And obviously, this is not working today. It was doing already checksums, and so this is pretty good, and it has kind of sort of an idea of branches, not really, but it had releases levels. So you can see upside and downsides. Then came this revision control system. If you are not as old as me, and if you haven't worked on Unix systems, this is still very early, still first generation. But multiple users could work on the same code base. Woo-hoo. So I mean, we are enhancing, and it already had the idea of branches, which I'm going to talk about later. We arrived to concurrent version system, which some of you might know. That's not as old as the earlier ones. I would define these as second generation version controls. It introduces the server client architecture. There's a repository on the server, and everybody has their own little machine laptop. You get a copy of those files, so you work on those files and upload your change. And on top of that, depending on a version control, this is just one example, sometimes you are not able to modify those files what somebody is already working on. The reason is that it's very easy to avoid any conflicts between the edits if you do that, but that's obviously very restrictive. In the real world, you often work on the same files if you're in a bigger software projects. Tags, I'm going to mention tags later. If you are, let's say, doing a release or an important milestone during your development, you can tag your source base at that time point. And that's going to help you to get back to that time point if something comes up. So those are tags. Subversion was kind of a better version, I guess. And some people rethought CVS and tried to make it better. Mostly compatible because of that reason. And I mean, these are small things like recognizing moving files. But if you have worked with SVN and you moved files, which I'm pretty sure happened, you know how painful is it when if you move files and the source control treats it as deleting one file and adding another, you break the history of that file. And that's painful. I like to, when I'm working on big code bases, then probably John Doe, who wrote originally and contributed several developers, are not there at the company anymore. The way I can discover a bug, why it happened, or I'm working on a feature is look at the history, see what happened, and forensically you can assemble some kind of reasoning in your mind, what happened, why. So, I mean, history is very important, and I would circle this back to, in general, version control. What can provide you is this history, the series of changes happening in time. We arrive to the latest generations of the version controls. What happened is you have heard of probably the Linux kernel, which is the kernel of the Linux operating system. They were using a specific so-called BitKeeper version control system, and suddenly it started to be commercial, so they tried to throw the developers off from the free tier. And so it wasn't just Linus Torvalds is a genius and somehow it popped out of his mind, the Git system, but he had a very good reason to like scramble and put together the Git. And to be complete, actually Mercurial, which is another distributed fourth generation system, was developed at the same time for the same reason of this BitKeeper debacle. And well, probably you haven't heard of BitKeeper, so they weren't good strategists. Git is world famous, and now it's a standard tool for everybody. So much so that I worked with Mercurial, but Bitbucket, which is one of the biggest Git server repositories. So the three big one is GitHub, GitLab, and Bitbucket. They dropped the Mercurial. They're gonna drop the Mercurial support. Mercurial is just as good as Git. It's just not as widespread. A little summary here, and I'm giving you some pointers to if you want to read more. But so let's see a little more. What's the difference between the distributed versus centralized? So here you can see that when I would work with CSV or CVS or SVN. This can be worker 1, worker 2. They are directly, when they are committing and making the changes to that certain central repository. Whereas when I'm using Git or Mercurial and I'm doing a commit, all I do is that I am committing my local working change to my local repository. Basically, I have a exact same repository copy, I mean exact same at the time of the copy, on my machine. And technically, now you are asking, hey Csaba, you said that it's distributed and not centralized, and here's the server. What is this server? Well, this server actually doesn't have to be there, so if these workers decide, they can leave that server off and they can push and pull to each other. It's whatever you set up in your Git, whatever is the remote end, that's where it's gonna push to. So, but for practicality, usually you have a server. You don't have to have. Now, I was just mentioning here commit and update and push and pull. And there are some other comments here in our tool belt. I didn't mention fetch and clone. So, and I haven't talked about staging. So let's talk a little bit about that. First of all, what is a repository? It's basically the tree of all of the branches of a source code, everything, all of the history of that project. It's basically a project. You can think about it like that. Fork. What is a fork? It's you take a copy and it becomes an independent copy and you can do development. But at the same time, when you fork, you always have the option to merge your changes back to the origin or other forks as well. I mean, even you have actually the ability to merge it to an not like an off-topic fork. Obviously, it will be a chaos because the version control won't be able to find a connection between the two. But so you can basically merge from any fork to any fork if you want to. Usually these forks contain some features or other changes, and once they are done, you merge them back and close off the fork to the main branch. I will talk about that later. Origin, probably I mentioned remote not so long ago, is wherever you set your local copy of the repository, which server-side copy it's connected to. Or so when you say push, where it's gonna go. That's what it means. Upstream, it's a term for the repo what you originally forked from. So actually, I would say the upstream, it's one step further than the remote, because let's say, later I'm gonna show you that on GitHub. But if you, let's show it now, okay? So let's say I want to contribute to some kind of a project, like, and I'm jumping now to, let's come here to the GDG Fresno where like this AR map software is open source. I want to contribute to this. I say fork. Now I'm forking it to myself. Right now it's at GDG Fresno. I forked it from there. Now, if I start to work on this and have a local copy, then what you see here on GitHub is the remote, and the upstream is this GDG Fresno. This is where it was originally forked from. So this is what upstream is. Remote, we talked about that, and I think I covered branches as well. Branches can be for anything. It can be for a hotfix. Whatever you do, you don't want to do it on your master branch or your developer branch. You always want to separate one for your purpose, and then once you're done with your work, merge it back wherever you want. So I was already speaking about this one. So normally, you have the master, and that's basically what the production environment takes as the code. Then you fork the master to develop. That's a generic branch which is long-lived. And eventually you open up these feature branches and merge them back once you have done developing the branch. So it's got tested by quality assurance and everything. You merge them back. The developer branch is always going on. And time to time, you are performing releases. The release will be yet again another branch. You open it up here. OK, I'm done with this feature. Now I do a release. I also done with other features. Open up this release, modify the version numbers and whatnot. Probably you want to run some tests, and then merge the release branch, which eventually it's coming from the master, so you are merging it back to the master. And the version control will help you to find the way back and see which were only the changes which happened, because there can be other changes in the source code. It will be magically able to filter out just those changes which are the difference between the master and the release. Actually, not magical, but with the diff tool. So the master is the mother of all branches. And when you are transferring some changes from one branch to another, that's the merge. I mentioned fetch in one of the diagrams, and that's basically just getting a change from a remote, and you are getting that in a separate branch. So when you are doing a pull, let's actually just go back quickly here. When you are doing a pull, what's happening is in a temporary branch, you get the changes, and you immediately merge those changes into your existing source. Then push is the other direction when your changes are merged into the remote. It's not necessarily a server. It can be your colleague if you set the remote there. Very rare, though, if you do that. Head, that's another terminology of where basically, as I mentioned, the version control is just managing history of your source, and each commit step is basically a time tick on this history, and the head points you to the current, normally points you to the current change, but you have the ability to move that head, and you say that, hey, I want to roll back and just take a peek. Like roll back not in a sense of forgetting the history, but just take a peek at like 2 commits ago, what was it? And so you can set back the head. You have the ability for that. Let's get a little more real. I'm running low on time. So you install Git. It depends on your operating system, different for Mac or in case of Linux, Windows. But after you install it, for sure, you must do some global settings, set your name and set your email. Now, the credential helper is not mandatory. I advise. We can debate on the security and whatnot, but you're going to see how I handle it. To make some spoilers, I'm using a password manager called LastPass. This case, whatever I do, I'm not worried about 20-character long passwords going around, and I don't have to remember anything. And sometimes it's less secure if you have to type in or do something over and over again versus if it's just in the cache. Now, we are just, let's say, we just have a command line, and I want to just work on a source. So let's say here, I am in this Csaba Technology organization, and I'm gonna open up demo1 repository. And I even initialize it with README, probably with license as well. I create the repository. Sorry for not doing this command line. You can do Git. As I said, I'm cutting off some steps, whichever is more faster, and it's gonna end up on GitHub or GitLab anyway, so it's just faster to do this. And okay, so now it's only living on the server right now. I somehow want to get this to my machine to work on. I go to this clone, copy out this address, and then I'm just here in the temp, and I say Git Clone. So that's our first workflow item. Then suddenly it copied this demo to this demo1 folder. That was the name of the repository. And I make some changes. Okay, let's see the Git status. That's something you can always look at. And I'm on the master branch. There's nothing to commit. There's nothing, no changes in there yet. This is in another view. And let's say I'm adding a file. And this is going to be just a text file. So now I created this text file here. I'm still here, and I say Git status. Now I have a new text file. Now what you see is I cannot commit this because it's untracked. And this is where staging comes into play. I can have many files or even changes in existing already versioned files. And I decide which of those changes I'm going to stage for a future commit. So this way, if I have 10 change files, I can break them up to 5 change files for one reason, 5 other change files for another reason, and commit them separately. In this case, what I will do is git add all. All change files with this. You can also enumerate which exact files you want to just stage. In this case, I staged the only file which is new. And I'm going to commit with a message, which usually is supposed to be descriptive and everything, so don't do this. It has to be meaningful, very important. And then finally, I'm going to now, I don't have any uncommitted changes, so now I can push it. Let's also prove to you that nothing is visible here in the server. Everything what I did here is just I was working on my working copy and local repository. So I'm going to do the Git push. And then, OK, so here in this time, it would ask for me my password. Since I was working already and it's cached, it didn't ask. Anyway, it's even faster. This is the reason. I don't want to enter it again and again. Now, if I refresh, I see this new file here. So that's a very basic workflow. It's if you see some kind of open source lab and you want to work on it and tinker, you want to keep a copy for yourself. And the tiniest project you are working on, the tiniest, just make a repository. Never do anything without a version control. It's something I learned. Pull request. This is a concept actually which is related to the workflow when you are dealing with a server, an involved server as well. And I will demo the pull requests PR later when we are talking about other tools. But this is going to be an important tool for others if you are working in a team to see what your change is going to be. Because let's say I have a developer a feature branch. My work is ready, but I don't want to just simply merge it back to the developer. I want the others to see it. They can have their opinion, what's wrong with it, etc. So I will talk about it later. Fork, actually I already showed that just for showing to you the upstream, what upstream means. So the fork means that you want to contribute to somewhere, and let me show you something interesting. What you can do is, let's say here, I'm going to go back to GDG Fresno. And I will try to contribute to a project like this old GDG Fresno. So let's say I am showing to you that even without installing anything on your machine, you can contribute to open source projects. What often happens that their documentation is wrong, and for the documentation, you can edit and say you have some addition or modification, right? Now, normally I would go through clone it, open up a separate branch because you don't want to work on the exact branch, and then opening up a PR. So in this case, I want to create a branch for this commit and create a pull request. And I say readme fixes. I am proposing a file change, and what's going to happen is that was just a commit, and you will describe it for the other developers what you found Sometimes it's the same as what's in the commit, but the commits can be multiple. And when it opens this up, it opens this patch branch automatically. And now I create the pull request. What's happening now is in the pull requests, I have this listed, and anybody who is a contributor, let's say you are not a listed contributor yet, not an assignee, not even a team member. I've contributed to Google, Microsoft, then you have to sign an NDA, not NDA, but some documents. They can decide then, they can get back to you that, hey, if you don't like this, can you make this change? Then you make that change, resubmit the pull request, and they can merge the pull request with this button click. This pull request is an extremely important workflow which fits into our other workflow. So let's move towards our workflow. I think I already described this type of workflow when you have the master which is representing the status of the production server. The develop is the staging server, and the feature, so master is, the production. The feature branches are your developer environment states. You are switching between features, what you are actively working on, and eventually merging it back. You never merge any feature branch directly to the master. It's always forked from the develop and merged to the develop. The releases are always forked from the develop and merged to the master. And there's one exception is the hotfix branch, is when you have some kind of fire going on. That actually crosses over these branch lines, and you are forking the hotfix. Here's the hotfix from the master. Then you have to up-merge it to develop and merge it back to the master once it goes through testing and accepted. That's a standard flow, and even it's phrased and called as Git flow. Here are the articles. What is very, and I will go into this, I would rather just show this Git flow cheat sheet because it's extremely well demonstrating graphically what's going on. So first, it describes the features, what I told you. It forks the feature, and instead of doing all the manual work, all of these steps are just one command. So it's one command to open up your feature branch. Each feature branch. It's one command to merge back once you've done the feature branch back to the develop. One command to start a release, and it's very well readable. Git flow feature start, Git flow feature finish. You always give a name, which should be some nice, meaningful name. And I mean, it's if you look, the release is the same pattern. So Git flow release start and release finish versus the feature start, feature finish, and the hotfix. So they really look very well learnable. Now, for reality check, here's this gist where you can see which command does what. So for example, if you are finalizing a branch, it's going to do 3 commands. I really don't want to type these. These are error prone. So if you want to, if you are, oh, I am a command line guy, I want to do this, but you don't want any repeated, like you have to repeat here these strings, and you can just forget a character or whatnot, wrong remote setting. You just don't want to do that manually. You want to rely on this Git flow. And the Git flow is a Git add-on. Sorry, I didn't say that. I navigated here. In the cheat sheet, it describes how to install Git flow. And let's this is one of the main tools I want to show you. Look at the release branch. It's like 6 comments. So I'm never going to type that on my own. I just don't want. You also don't want. And very, very widely used. Very easy. So let's say, let's have a quick demo. I have 15 minutes left, or a little less than 15, I think. So let's do another demo. I am starting with the clone demo 2. So I'm going to clone this demo 2. And I'm going to show you, because in my previous demo, we, besides that patch, what I did graphically, that patch PR, I didn't have anything else. Now I also only have here the master branch still. Now I'm going to navigate back and I say Git Clone. This is standard Git right now. But I'm going to navigate into this new project. And I say git flow init. Now it asks me which one is the production master. Basically, can you read it? I'm so sorry. Let me quickly, just a second. I just realized that I'm torturing you guys. So I don't want that. Okay, so branch name, the next release will be the development. And that's true because you think about it, the development is always the staging, and the next release will be branched and come off of that always. Feature branches will follow this, a naming convention, Buckfist follows this convention. These naming conventions are fine. So I'm just following what it does. Now, we still just worked here, so on the local branch, although something happened, I got switched to the developer branch because you never want to work on the production. You also never want to work on the developer, you want to work on a feature branch, but right now I don't have any feature. So I say Git Push because all of this, what I have, nothing is here yet. I have to, that's right. So see, this is the thing, Git, I want to do Git Push. Well, so, okay, now this is not master. And I think I'm going to jump ahead because I'm short on time. And I'm going to show you these workflows. I will show you how to start a feature and finish a feature. So what's happening is we can work on multiple ones, and at the end we always push the end result. In between we always pull, by the way, so I'm not adding the pull. Every time you always want to in sync with the server. And we can do a release. What I want to go, and I will show you a hotfix. This is how it goes. It's you start the hotfix, apply the changes. You always want to upgrade the version, commit the stuff, and finish. Then once you finish, you once again have to push. I want to talk about Git Town. So Git Flow is an add-on, and Git Town is also a set of commands which makes your life easier. And the reason I'm doing this is the Git sync. Git sync is kind of a bread and butter for me. I just do it all the time. It's like breathing. I go to a branch, Git sync. And then I know that nothing is out of whack. Because here, it's like, I don't know. It's like upstream and origin and develop, what is this? So what I would do normally is git town sync. I aliased git town, so I don't have to type out git town. You would normally. Now, since I haven't configured git town, it's going to ask me which is the developer branch. Basically, I'm doing a git town init here. I say, okay, develop is my developer branch. Master is the upstream branch for that. It set up everything, and it just does it for me. It doesn't only, it synchronized tags if I haven't pushed any tags. It pushed up all the branches for me. So let's look. So the developer branch is already there. And if I say here git, so I am mixing git flow and git town. But I will show you how you can use less git flow. I'm not against git flow, by the way. So I say git flow feature start and okay, this is very sloppy. But now I am in feature. You remember that was the convention feature F1. And so I'm on that. And the feature, I'm going to add feature A, feature B, feature C. I will add this file. And this is, I will say, features text. So I created this file. And another, I won't have time to show you. Probably, maybe I will show you some graphical user interfaces, but you can be graphical even on the command line. TIG is a graphical ASCII art Git tool, what I often use. I can see the question mark here means that features is untracked. I stage it, so now I staged it, and then I am using hotkeys here. I'm adding features list. Okay, so now I did that, and Git status. So there's nothing to commit. Now I'm gonna git sync, which we're gonna perennial branch is the develop. So feature comes from that. So it syncs my feature to feature 1. And now I say, this means here that I have now feature 1. And even GitHub warns me that there's this new feature. And that text file is only in that feature right now, not in the develop. So what I say is git flow feature finish. Let's say it went through testing and people, I'm not using yet the, so for a complete workflow, you would use the PR workflow. You would want to open up a PR if you are in a team. I'm simplifying stuff now. This, so it finished, and I say git sync. Which git sync is a git town command. So with the git flow, I close the git flow feature branch, and the git sync is, please don't. Oh boy. Demo gods, please. Demo gods.
I just lost Wi-Fi too.
What? Yeah, what happened?
I'm back though, so I think it's reconnected.
Oh my God. Okay, this is kind of sort of bad for a demo which wants to, like, for real? Why is there's no? That's really demo gods. Okay, so something bad happened here. Don't do this with me. Okay. Give me 1 minute. I'm gonna tether. I mean, this is really challenging. In the meantime, so Git, I know that it might be a little confusing. You can look up my links for Git Town and Git Flow, but I'm just demoing right now the Git, mainly the Git Flow. Git Flow release, Git Flow, hotfix and stuff. And just a second so demo guts. So maybe this is Murphy's Law. So it's like, oh, okay, you run around. Okay. All right, so let's get back here. Let's see where is our, how. All right, so we don't have that feature branch anymore. It got closed down and got merged into the develop. You can imagine the hotfix as it's happening. And how many minutes I have? Like 13?
I think it's 4:30. We stop. We go to the next one.
4:30.
I think so. Yeah.
Not 4:40. All right.
Let me check the schedule.
All right.
Sorry.
All right, you guys.
Let me check it.
But then Git Town is the pinnacle. What I want to, it has another workflow I use. Instead of Git flow feature start, feature end,
4:30. Go to that networking.
I am doing Git Town hack. So here I say Git Town instead of Git Town hack feature 2. Now I'm on branch F2. Since it's not Git flow, it didn't follow the feature / naming convention. So you have to watch out for that. Now I am doing other stuff here. So let's do some modifications, and I add feature D right here. Okay. So now if I go in with TIG, I see that features is modified like that. And I'm gonna stage this and commit as well. Now, it's not pushed yet. What I'm gonna do is I will come here to settings and I say branches, and for the developer branch, I'm adding a rule that it requires pull requests require review before branching, and no stale require review from code owners. So I create this rule, and so now if I do Git down, sorry, I didn't name the rule, but we just code owners, okay. So I save this, and instead of, so I remember that I started this workflow with Git down hack instead of Git flow feature start. Closing this feature is Git ship. So the pair of the Git down hack is the Git ship. Also the Git down new pull request. Let's do Git down. And the good thing here's the pull request, is that it's there right now. And if I want to say, oh, wonderful. If I want to say git town ship, and I don't even have to specify which feature because I am on that feature branch, it will try to ship it and do the merge up at the server, not locally. So try to ship feature D. And come on. Okay. I didn't set up the rule. What I wanted is this PR, this ship to fail because the PR wasn't accepted. I don't have time to redo this, but the bottom line is that you want to employ these safety features that you don't want to any commit without a PR. You want your colleagues to review your PRs, and this is basically all safety nets in all stages of development as you merge from one place to another, following the development flow. Try to avoid errors and not let things slipping through the cracks, kind of connecting back to security as well and code quality overall. If you follow these best practices, will help greatly your software project and yourself as well. Check out Git Town, Git Flow. Please ask me any questions later if you want to. I didn't have time to demo in GUI, or GUIs have good support. So I don't know if we have any time for questions, but you are welcome, even if you don't have right now, to come to me anytime or contact with me. So, wow, that color is really off. Okay. Thanks for listening.
Thank you.